Welcome to Analysis 1A, Lecture 4. We ended last class we were going over but sort of ran out of time. Limits Review 1, this worksheet, is that visible?
Yeah.
And so now we're putting some of the problems up on the board. Guys, keep in mind that the directions for these problems are show your teacher that you know what you're doing. So that means work, explanations. If explanations are trivial, then, just do it. If it's algebra, just do it. If it's a graph, draw a picture of a graph. If you're claiming that the limit does not exist, then you need to say why. And your why should include, the limit from the left does not equal the limit from the right. And while doing that, you should tell me what the limit from the left is, tell me what the limit from the right is, etc. That when you need this worksheet?
Yes, the number 2 one.
Oh, the number 2 one. Do you have the number 1 one?
Yes.
Oh, okay, good. So you are kind of. You didn't lose anything. You just failed to take proactive measures.
I just forgot to realize there's papers on there, so I was like, forgot to realize. I got to realize.
Maybe if we can even start going over limits review too. Let's do that. Yeah, let's do that too. You guys who do the front, right?
Yeah.
So let's put the limits review 2 problems up also. 1. You can space it out a little bit. Yeah, so come do these also, please. Do you guys need more markers?
Yeah.
There are some.
I'll do 14.
Here are 3, and then you could grab one from the front, maybe.
14.
And it was bookwork also, but it was like pretty short, right?
Yeah.
Yeah.
It was really short, yeah.
Same. I was like, what?
I don't think
At first I thought they were going to be like these really long proofs, and then when I did them, I was like, wait, it's just...
Yeah, that's what I see. There were only 5 problems, but I thought each of them was going to be a proof.
Like, first you had like 4 problems that are like really long
I don't
proofs.
assign problems, unnecessarily. But yeah, anyway. All right, I think we can basically start just about. So I think this is where we left off last class. We did maybe 1 through 6. Hopefully we did. Number 7 is the limit as x approaches 3 of the 6th root of 81 minus x to the 4th. This is another kind of technicality thing. So this person says, all right, let's plug in 3. When we plug in 3, it seems to be 0. The issue, however, so yeah, when I take the limit as x approaches 3 from the left, everything's fine and I get 0. But as this person has realized, if I try to take the limit as x approaches 3 from the right, when you raise 3 to the 4th power of a little bit more than 3 to the 4th power, you get a little bit more than 81, and now you're taking the 6th root of a negative number, and you just can't take the 6th root of a negative number. So this is absolutely correct that the limit from the right does not exist, and therefore we say, kind of by convention, that this limit does not exist. All right, this is very much not the graph of arc cosine. Wait, what's going on here? There's experts. Arc cosine of 0 is pi over 2, but it's just not what arc cosine looks like. Right? One of us is wrong.
That is wrong.
That is definitely wrong. Yeah. When you take, what's the arc cosine of 0 is, sorry, arc cosine of 0 is pi over 2. The arc cosine of 1 is 0. So, and the arc cosine of pi is, or rather, the arc cosine of -1 is pi. Arc cosine kind of looks like that. Okay, so, what? No, but there were no, you had like arrows going like off asymptotically. Oh, no, it didn't look like this. It looked different and worse. There's video evidence. Go back and check the record.
Oh my God.
This is what it looked like. All right. So anyway, but the answer is pi over 2. There's really nothing to say there. That's just like, hey, do you remember your pre-calc? Yes, you do. Limit as x approaches pi over 2 of tan from the right is negative infinity. I agree. You are awesome. Number 14, this is just like the limits of sequences stuff that we did last semester, and this is exactly what you were supposed to do. As long as you take the limit as x approaches infinity, you can kind of tell just from looking at it that the answer is going to be negative 7/5, but I do want this kind of work shown. And this is how you should treat any rational function when you're taking the limit as x approaches infinity or negative infinity. You can divide the top and bottom by the highest power of x in the denominator, and just like she did, we get all this stuff, and all those things obviously go to 0, and so the answer is negative 7/5. Cool, cool? Okay. Number 9, I realize I'm skipping all over the page, but nonetheless. What is 9? 9 is limit as x approaches infinity of stuff. And then, again, a rational function, so we're going to multiply, we're going to divide the top and the bottom by the highest power of x in the denominator, and we get stuff, and so the answer is 7/4. Yes, good job. Number 15. Did you guys realize what that is? This was supposed to be the, I think when I made this worksheet a couple years ago, I didn't know how to make this symbol, so I just used this is supposed to be floor. This is floor, like comp sci floor, greatest integer function. So, usually in this class, or maybe in pre-calc A, you guys wrote it like this. But anyway, you should recognize different notations. What does floor look like? I need a graph for this. I think this might be the right answer, but I don't know that you know, or if you're just guessing. What does the graph of floor look like? Well, it's not just floor, it's floor moved 1 to the left, right? So floor moved 1 to the left looks like this. I think that's right. And so what I'm interested in what's happening at 3, so 1, 2, 3, so I need to go up like one more step. And yeah, now to label this axis, that's 1, that's 2, that's 3, and that's 4. All right, this graph's looking a little sloppy, but hopefully it's readable. And now that I'm looking at my graph, I agree with everything that this person said. The limit as x approaches 3 from the left is 3, but the limit as x approaches 3 from the right is 4. Therefore, this does not exist. Cool? 10. This is a classic application of you can split the limit of a product up into the product of the limits. And yeah, that's what this person did. They basically just plugged in 0, actually, is what they did, and they just got 3. I totally agree with all that, right? But if you wanted to, you could even break it down further by splitting it up into 3 separate limits, and they're each 3, but that's probably not necessary. All right, 16, limit as x approaches negative infinity of 2 to the negative x. Basically I agree with this. Yeah, the answer is just infinity. You could just provide a graph, maybe. I guess it's not totally necessary, but that's a graph of what 2 to the x looks like, so I think we're good. Questions? All right, cool. Number 11 is, explain. Yeah, I don't like this answer. Who did this one? Yeah, okay, you're right, and I kind of know what you're talking about, but like, what happened? Like, okay, then you need to at least like write that somewhere, right? Because it's just like you need to at least write that somewhere. Can anyone do this like a little bit differently with a little more, perhaps a little more formalism? Yeah, Kendall.
I just had like n equals 5x.
Yeah, you could do like a variable switch. So she says let n equals 5x, and then we do the variable switchy. This becomes now the sine of n over, well, x is now like n over 5. And now, essentially what I'm doing is I'm rewriting this entire limit in terms of n instead of x. And as x goes to 0, if n is defined to be 5x, then n is also going to 0. And so this is just the limit as n goes to 0 of 5 sine n over n. And that we know is 1, so that's 5. I don't know, I feel like it's a little bit better. What you did is fine too, but you need to at least write me that little parenthetical sentence like, this is so because. Yes?
We don't need to write that though for sine n over n.
Yeah, this is like a limit that we have previously discussed, so then you just say that that's 1. Is that that's your question? Yeah. Okay. What's going on for 17? Looks complicated. Did I make you factor that or something? Oh no, it was already factored. No, it wasn't already factored. You had to, yeah, you had to, wait, or was this another problem where I tried to do something cool and it didn't work out? Yeah, I think if you just plug in -1 here, you just get 12. So the answer is just 0. You didn't even need to bother factoring it. Yeah, the answer is just 0. The numerator goes to 0 and the denominator doesn't. So it's just guaranteed to be 0. And number 12, this is just another silly problem. I don't even know why we're going over this. You plug in pi, you just get -1/pi. All right, good. Let's move to limits. We were supposed to do that last class. Let's move to limit review 2, which is a little bit harder. And I'm going to have some more comments to make here. While I'm doing this, can someone volunteer to erase this board?
We only did the.
I can do it.
I said only to the front, only to the front, yep. Or a room can do it, yeah, you can do it. So, let's talk about this. Alright, we've seen this function. Did we talk about this function already last class? I feel like we did, right? I called it like a singum function or something like that, which is like Latin for sine. I'm not sure I'm actually pronouncing that correctly, but it might be. What does this function look like? Answer exactly like this. If you plug in, I'll just keep repeating this over and over again because it's important that the definition of absolute value of x is that it's x if x is positive and negative x if x is negative. And so, basically, if you give me a number which is larger than 3 or equal to 3, then this numerator is just going to be x minus 3. And so, yeah, you get 1 if you plug in a number larger than 3, you get 1. If you plug in a number smaller than 3, you get -1. Or you can just memorize, not memorize, but if you just know what that function was which we discussed last class, then it's just that move 3 to the right. That's probably how you do it. So once you have a picture, then it is beautifully obvious that the limit as x approaches 3 from the left is -1, but the limit as x approaches 3 from the right is 1. So, so what's the answer?
Yeah,
You did everything but give the answer. What's the answer? It does not exist. And it does not exist because this is exactly the kind of work I expect to be shown. Alright. Number 2. It's very interesting. Talk to me about this. Who did this one? Yeah, Laura, talk to me.
So I like factored out an x squared, so I could, and so once the x squared was factored out, it was stuck under the square root thing, I could pull it out. And then once you had that, you just had like the kind of same thing we did with polynomials, so you have 1 plus 2 over x squared. And then 2 over x squared was 0, and so then I just said that x times root 1 minus x equals 0.
Alright. Okay. It turns out that the answer is 0. This is kind of a bad problem from a learning experience because even if you do it perfectly, even if you just do a bunch of crap that's not actually valid, you'll probably get the right answer anyway. The right answer is 0. This is some questionable moves happen here though. In particular, like this partial evaluation can get tricky. I cannot think of an example at this exact moment of where this will go wrong, but generally you don't want to, if you're trying to figure out what some function does as x goes to infinity, and you sort of like, well, let me just deal with some of the x's for the moment, and I'll like let them disappear, and then I'll like, oh, other ones I'll leave in there, yeah?
Can you do like function, like f of g of x, and then just plug in the limit of g of x for f of x? If the limit is like f of g of x is x goes to whatever.
Yes. Yeah, that was a thing in the book. Okay, let's pause for a minute, and we're gonna come back to this in a second. Let's pause for a minute. I want to convince you of something, so what form does this limit take? Like, well, how would you describe the general form of this limit? That's kind of a vague question. Yeah, right, Fleishman, what am I talking about? What am I talking about? Yeah, what am I talking about?
It's 2 functions subtracted, like limit of f of x minus limit of g of x.
Okay, yeah, so it's like one function minus another function, but specifically, like, you know, what makes it sort of weird or hard?
The square root of
Yeah, Kendall?
Infinity minus infinity.
Yeah, this is, I would call this an infinity minus infinity situation. And in fact, so what is infinity minus infinity?
Whatever you want. Depends.
Yeah, it's not necessarily 0. I think it depends. Let's do a couple of examples. So here's an example. Let's take the limit as x. Everyone do this now, like on a piece of paper or something. Let's take the limit as x approaches 1 of 1 over x minus 1 minus 2 over x squared minus 1. This looks kind of fun. By the way, what form is this limit in? What is this guy on the left going to? I have to do a little bit of math. To plug in a little bit more than 1, then the denominator is like a tiny positive. This is going to be infinity, right? Right?
Yes.
How about this one?
Infinity.
I think also infinity, right? Because a little bit more than 1 squared is going to be a little bit more than 1. Minus 1 is a tiny positive, 2 over tiny positive. So this is definitely an infinity minus infinity form. What's the answer? Carson, what's the answer? 1/2. 1/2? Where are you getting that from? Oh, you just did it on your head. Oh man, you ruined it for everyone else. Maybe the answer is 1/2, or Carson's wrong. Try it. He's right? Oh man, guys are too smart. People at home, don't try to do algebra in your head like Carson. He's too smart. He's been training for years. Yeah, do the problem. Yeah, you have to just try. You have to do math. You have to do some kind of math. You need to do some algebra. So I'm going to do that right now. Wait. Oh no, I have to go back. So I guess I can get a common denominator, right, by multiplying top and bottom by multiplying the top and bottom by x plus 1 of the guy on the left. And then, oh yeah, stuff happens. You guys getting what I'm getting? Oh, he was right. He was right, 1/2. That's a little bit surprising. Raise your hand if you're surprised. I'm surprised. 1/2. Wasn't expecting that. Yeah. Infinity minus infinity is another one of those indeterminate forms. Do we have some examples of this? I bet we do, right? Like, yeah, give me a couple examples.
Limit as x goes to infinity of 2x minus x.
And the answer is? This is the easy part. What's the answer? Infinity. Okay. Give me another one. That's also of the form infinity minus infinity, yet the answer is something different than infinity. How about just x minus x? I mean, if we're sticking to such easy examples, we might as well, right? It's just x minus x. Is that in the form infinity minus infinity?
Yeah.
Yeah, what's the answer?
Oh, this doesn't help me get it.
0. How about the limit as x approaches infinity of, give me a different one, where something different happens.
X minus 2x.
X minus 2x. Yeah, what happens now?
Negative infinity.
Negative infinity. Alright, so then that just about covers all, yeah.
Like quantity x plus 1 squared minus x squared.
Yeah. That's just going to go to infinity, right? Or something?
Yeah.
No.
There's
Yeah.
another 2
No, infinity.
I think it goes to infinity.
If the x plus 1 together is squared minus x squared.
Then you get 2x plus 1 at the end.
Yeah. Yeah. So I mean, this is already convincing enough to me, right? I simply cannot. This is a proof that this is an indeterminate form. When encountered with infinity minus infinity, I cannot just assume that the answer is going to be 0. Sometimes it could be infinity, it could turn out to be 0, it could turn out to be negative infinity, or it could turn out to be like 1/2, right? All right. So how might I do number 2 in a little bit more organized, systematic fashion? Should I just like wait? Let's see, what should I do? Yeah, that's exactly what I should do. But problem 2 is pretty boring. Let's do another one. That's like hard. Let's do this one. Let's do the limit. So again, this would be in your notes. The limit as x approaches infinity of 2x minus root 4x squared plus x plus 1. No? Yes. Alright, so Gayhart, we should cycle through the 7 stages of grief or whatever, right? You should look at it, and you should just kind of make a guess. it's important when you do math to try to like guess first. Some of you just do this anyway, because if you're lazy, like lazy in a good way, like yeah, like you're like lazy in a good way. So you try to look at something like, man, how can I just get out? How can I just get out of actually doing this some way or another? Yeah, so try to come up with use your intuition and try to come up with what you think the answer is, but then actually confirm that your answer is correct with like follow-up algebra. And then if your intuition is correct, then that's kind of boring. But if your intuition is incorrect, then a learning experience is available for you to sharpen your intuition and perhaps refine it in some kind of a way. What do you think the answer is?
I think the answer is 0.
Yeah, that's a very reasonable, intelligent conjecture. She disagrees. Why do you think it's 0?
I think it's 0 because I think when x is infinity, x squared is a lot bigger than x. In fact, I think it's so much bigger than x that you really don't care about the x. Oh, it's...
Wait,
yeah.
you see the square root, right?
Yeah, I'm talking about the x inside the square root.
No.
Oh,
I'm saying
okay.
I don't really care about that x. So, and you really don't care about the 1 because that's just like still 1 even when everything else is like 10 trillion.
Yeah.
So then when you just take the square root, you kind of get 2x minus 2x plus like a tiny bit that really doesn't matter compared to the 2x.
Yeah. Everything he's saying is very convincing.
No.
We have been trained multiple times when considering polynomials that only the highest power term is like relevant, right? So he's basically saying that, yo, this is like about 2x. Is this what you guys are more or less thinking also? This is like about 2x. And this is like about 2x. So, I don't know. Oh, counterpoint. Emma.
No, but it's like about 2x plus like infinity.
Wait, what?
It's
Oh.
like so if you just like thought that's about 2x, it's 2x a little more. That little more happens to have an x or a root x in it, and x is going to infinity. So
Yeah.
you can
Oh,
let
Robbie
those 2x's
Fleischman,
go to
you're
0.
so-called so small that it's not important that I could ignore it because it's trivial. Is actually growing pretty big, right? So what do you think the answer is?
Infinity.
No,
Negative infinity, right? Okay, so that's what Yael thinks too. Okay.
Wait, I have a question.
Wait, why would it be?
Wait.
She thinks negative infinity because this is what Emma thinks. This is what I think she thinks, and Yael. That
Oh, yeah,
4x squared is more or less 2x, and so those will cancel, and so you'll just
Those
get
are
now you'll be
negative, yeah.
subtracting something which is quite big. All right, enough of this talk.
Wait.
What?
What's the Really answer? important question. Do you have any Kleenex in here?
I do, yeah. It's a giant box. See, you have to be tall.
Hey,
You have to get
Daniel.
it. Yes. But now I want to do the problem. Can we do it?
Wait, no.
Oh, maybe you don't know how.
Yeah.
How do you do it?
No, it's like another thing.
No, I'm tired of talking about your feelings now. No. Your time for your feelings is over. Now you have to do math. There is a way which Buse has suggested, which is not obvious at all, yet seems to always work when like square roots and stuff are involved.
What did he say?
No, like the square. What? No, what should we do?
Multiply by the
Multiply by the conjugate. Everybody do that right now. Go.
What?
No, start. No.
Okay, but I'm so confident in my answer.
You're so confident.
Well, I'm confident too.
I'm gonna come over and talk to you in a minute, but first start the problem. Yeah, you. I think
Both of
you're
your confidence needs to go down like a couple levels.
Somebody.
Their confidence. It's like
Everyone will get a note card as they leave today. If you get a blue note card, it means your confidence is too low and you need to, give yourself a pep talk. You
Can I
look in
give
the
it out?
mirror. If you get an orange card, it means your confidence is too high and you need to shut up and, Okay, no, just kidding. What?
What's my card color?
Oh, man, it's like deep burnt orange. All right, good. It's all going on the video. So it might be fire.
Wait, no, this isn't what they found. Okay.
Just for the record, that was sarcasm. I love you all. You're doing a great job. But
Looks like you have one.
wait, no. Do the problem. First, do the problem.
I did.
What'd you get? Don't say
Something
anything.
bad.
Yeah, keep going. No, finish it out properly, dude. Get an answer. Then think. You don't need me.
No, it's unrelated.
Okay.
No, but this time when it's on the bottom, it's like helpful.
2, I got 0.
We probably should have done some other problems first. This one's like pretty hard.
No, because on the bottom it's now it's like.
No, we could have done number 2, but you erased number 2 and said, no, it's not number 2, that's too easy.
It's true. I was gonna say.
You could say, sorry, I owe you $10,000. Put the
Never apologize.
back in
I have
jail.
an orange card also. Alright.
I think this is here. Smaller.
No, I get.
I think it's like this.
I get like.
So it's like 4x squared minus
Like
4x squared.
It's like, I need like one of those.
Like that, right?
Infinity on top, you can have like an infinity
So we know that this is minus 4.
I feel like mine would be like mine be so
Oh yeah, it's not.
It would be like black. Like,
oh I know. What?
Alright, so now we're gonna get the limit as x goes to
because
infinity
it's not like, you're not.
of negative x
You're like,
minus 1 over
no, it's just like,
So it's gonna
you'll
be
get you'll get the green.
Okay, now what? Now I got it down. Now I got it down to this point. Now what? Now is you're starting to have an opinion. Is this where you guys are? Or further? So now is it coming into focus? What's going on? Do you have a new opinion?
Yeah.
2x negative. Because it's.
You still think it's negative infinity?
No.
No, now I don't think so anymore. Because now it's like a linear over another linear plus of something which might as well be kind of basically linear, right?
Wait, so why are we doing this? Why
It's
does
hard.
it help?
Yes, yeah, it's helping us learn that our intuition is not to be trusted.
I never trust.
What should we do now? Which what? Did I mess up?
No.
What should I do now?
We should factor 4x squared out of that bottom fraction.
I don't think I need to factor it out. I think something at Emma.
Just divide everything by x.
Yeah, Emma says, okay, it would have been helpful if we had already gone over number 3. Let's like quickly do that. Oh. Let's like pause that problem. Go over here to number 3.
Just like we paused like
So number 3 was the limit as x approaches infinity of root 3x squared plus 1 over 4x minus 2, right?
That was easy.
That was kind of easy. Is that what you got? Root 3 over 4?
Wait, no.
Uh-oh. Okay. So it's not that easy then. So again, if you think for a second about what's happening, Matteo, over here, this is a quadratic on the top, but you're taking the square root of a quadratic, so it's like roughly linear. And on the bottom, it is linear. So actually, my common sense tells me that when this is really, really, really big, this is going to look approximately like root 3x, and it tells me that the bottom is going to look approximately like 4x. And that is basically exactly what this person did up here, and they got the answer root 3 over 4, which is correct. Okay? But, and I like that, it's a little sloppy. So what we can do, which is what Emma suggested, is, and we did problems like this, I think, last semester, I thought we did, that even though this is not technically a rational function, we can treat it like a rational function, and we can use operations like we use with rational functions. And so the thing to do is to divide the top and bottom by the highest power of x in the denominator.
Okay, that's what I did.
Good.
So what, like?
So I don't know, maybe something went wrong later. So now if we divide the top and bottom by x, what results? Well, this becomes the limit as x goes to infinity of, well, the bottom is easy. The bottom is going to be 4 minus 2 over x. What happens on the top, though, is that now I have to like put 1 over x back in jail, right? And what happens when you put 1 over x back in square root jail? It becomes 1 over x squared, right? So, because it's mostly true that 1 over x is the same thing as root 1 over x squared. That's I'll just say mostly true. So to be continued on that. But that's more or less kind of true. So when you put him back in and you use your algebra skills, this turns into root 3 plus 1 over x squared. Everybody with me? Okay, and now it is very, very clear that as x goes to infinity, this goes to 0, and this also goes to 0. And so we both ended up with the same answer, but I just like my method is a little more tight. All right, so there it is. The answer is root 3 over 4. I feel like I can do the same thing here, right? So do it. Again, multiplying the top and bottom by 1 over x, because this is also kind of like a rational function, though it's not actually a rational function. Because rational functions are ratios of polynomials, and that denominator is not a polynomial, but kind of close enough. Like here? Yeah, I don't think so. Everyone, if their head's in the way, then tell the people to like move.
Well, I've just been moving around them. It's fine. It works out.
Did you get what I got? Am I going too fast or are we cool? This goes to 0 as x goes to infinity, so does this, and so does this.
Okay, well.
And so, this is basically like the top is more or less -1, and the bottom is more or less, everybody? 4. Yeah, final answer, which we are simply just not smart enough to have done in our heads by just pure prediction, or at least I'm not, is -1/4. Yeah, you.
Couldn't you have done the same thing by like completing the square and the square root, and then you get like something squared plus some insignificant number, and then since you have that something squared, it would be like, yeah.
Have you tried this?
No.
But you try this? Because I don't know what you're talking about. I kind of want to move on, but you might be doing something really brilliant. Just try it, and if it works out, then let me know. All right. Anyway, everybody cool with this? Mateo, proof that first off, infinity is really weird and hard and complicated. You can't use your intuition. You have to use algebra. Secondly, we have given yet another demonstration of an infinity minus infinity indeterminate form. And when you have this kind of situation, yeah, you multiply with the conjugate, that's what it works out. All right. Let's continue to go over the other problems from this page. So number 3 we already did. Number 4 is just like a throwback. This is the easy problem. Basically, it's a 0/0 indeterminate form. You multiply top and bottom by the conjugate. Simplify. Happiness results. Answer 1/10. Number 5, I think is also pretty chill. This person did it by simply expanding x plus 3 cubed via like binomial theorem or not even. And then you just do things and you get 27. Is that okay? I don't think we need to go over that too much. Number 6, this is another rational function. You can kind of guess again that the answer is 2/3. So but I'd like you to do the work that was like that this person did. Number 7 was also pretty straightforward. You have 0/0 in the top and the bottom, but if you factor it and cancel, you get 6/5. Number 8, what is this? What's going on here? Oh, there's some weird piecewise function, but since we're taking the limit as x is approaching 1 from the right, the left piece becomes just irrelevant, and so this might as well be just the limit as x approaches 1 from the right of 3x minus 1. And that is just 2. So, great. Okay, you're going to do the rest of this for homework. I thought there was like one more problem I wanted to do. Oh yeah, did we do, let's do 2 more problems really quick that are also just of miscellaneous nature. Let's everybody do this problem, the limit as x approaches 0 of x over x plus 1 minus root x plus 1. I think this was supposed to help you so that you actually were smart enough to do that other problem, but oh well, we're doing it out of order. And another problem which is kind of an issue is this one. The limit as x approaches negative infinity of root x squared plus 4 over 3x minus 3. Okay, go. Take a minute and do those. What? Yeah.